So hi and welcome to this afternoon session on source generators. My name is Martin. I'm from Vienna in Austria, although I do work for a Finnish company. For TTEvery, we're around 300 people in Austria. I got into .NET mostly through being active on GitHub and on Stack Overflow. So I think when .NET moved to basically a pure open source model, that's what I really got involved. So if I told myself 10 years ago I would work with a lot of Microsoft technologies, I wouldn't have believed myself. So what I want to do with you today is I do have a few talking points, a few slides. The rest is going to be a lot of demos. And even though I did not update VS today, although it wanted me to do it very much, some things might not work fully. If you see an error, tell me. More programming. And I also want to show you what's in .NET now that hasn't been there 2 years ago. And we're also going to build our custom source generator. So I'm very excited to do that with you. So first of all, source generators, or actually metaprogramming. What's our motivation for that? We don't want to write boilerplate code. Like we like to solve problems, we don't really like to type. So if you have to type less, perfect. Then there's these things like aspect-oriented programming, where like we know how to do logging, we know how to do synchronization, we have some logic that we can do detection with, and maybe we just want to add this to our programming. I think the most used case is actually serialization. So we know how objects look, we know the properties that we have, we know how XML works, we just don't want to write the wiring code manually. So we like to have this generated. And of course, we have schemas. So maybe we want to generate code from schema. Maybe we want to generate schema from code. And that's what we use metaprogramming for mostly. So what options are there in .NET? Well, first of all, reflection. I think you've probably all used that at some point. If you just iterate over types, iterate over properties, methods, maybe invoke them, like reflection invoke. But this is then also used in combination with IL generator. So we can generate IL code at runtime and have the JIT compiler actually compile it at runtime and run it. So for example, I think Dapper does that. It's pretty impossible to debug because there's no source code you could attach to. And now that we're moving to ahead of time runtimes, that's actually not really a good option. I mean, some runtimes ship with an interpreter for these things that you generate in IL, but your point was to be faster, so not a good thing to do. And of course, there's always the possibility to add custom build steps. So we have the MS build system, we can hook into that, we can create our own build steps, but even .NET itself had some build steps. So even in .NET Framework, you had these generate serialization assemblies checkbox, where it would just pre-generate that .xml serializer.dll. So your first invoke to like XML serializer would be faster. ASP.NET used to do that in a custom build steps. When you have this like Razor source code, it would generate C#. This has actually changed now, and I'm going to show you. But also other tools have been using that. So Protobuf was making use of that very heavily, for example. And then, of course, there are IL weaving tools. So if you don't want to mess with the compiler or the source code, you can actually modify the binary after it has been built. So there are tools to do that. So Fody, it's an OSS project, but they will not support you if you do not sponsor them. And there's PostSharp, which is a commercial offering. And I think they're both worth the money. Like there's still things you can't do with other features or other ways of trying to do things, but it's really hard. Like if you rewrite some methods in the DLL, in IL, how do you debug? Do you generate some code that matches what's in that? Or Do you want to show the user where they would be if they had run the binary as is, but it has been rewritten? So if you talk to the post-sharp guys, they will tell you how much pain it was to hook into the Visual Studio debugger to make things like stamping actually work in rewritten DLL files. But we have a new option. In C#9, so 2 versions ago, we got source generators. And they do what the name say. You can generate source that will be added to your project. But it's also everything they can do. You cannot rewrite code, you cannot rewrite implementations, you can only add code that the users could also have written themselves. So if you need to do rewriting, maybe IL weaving is still the best option here. But there is no hooking into the build process after the build process. It just runs in a compiler. So it's a single compiler run. Like if you had any custom build steps, you would have to load all the source code, parse it, compile it, generate something off it, and then the actual compiler would run and process the generated files. This way, one compiler run, we only need to load the solution once, and at some point the compiler stops, does here's all the source code. Look at everything you need, generate code, and then it will just continue the compilation as if we would just have added more files in the IDE. So that was C#9 that was introduced with .NET 5. But in .NET 6, we first started to see like built-in generators in the actual runtime. And some more in 7. And that is something I want to show you. So, yeah. So first thing, system text JSON. Pretty much replaced Newtons of JSON in most use cases. And we can have our custom types. In this case, it's a class, person. I've prepared some JSON file that I want to deserialize. And I can just use the JSON serializer to deserialize and serialize these objects. Let me just check if that works. Yeah, so that works. Now, behind the scenes, this will generate some code to do the actual writing of the actual serialization, so writing out the tokens. But it also has to do reflection, like loading the person class, looking at the properties to do the deserialization. The thing is, I can actually do that ahead of time. So in .NET 6, we got a JSON serializer context that we can inherit from. We have to mark our classes partial, because we can only generate to classes that allow extensions with like partial. And we can use a special attribute to tell it, generate the JSON methods for that. So I should be able I have a default that was generated and it's ilist person. And no, I don't want to do it to string. Perfect. Now this becomes not needed. I can do the same thing for serializing. So, but why does that help us, or what does it do? So we can actually have a look. So Roslyn uses their existing plugin framework that they also use for analyzes. So everything should show up here under analyzes. System text JSON source generation. And here it is. So we can have a look at a few things. That's actually the JSON context. Let's look at person. So it apparently found out that we have kind of a few properties. Here's like the first name property and all this, its configuration. You can also see there are strongly typed getter and setter methods. Last name, age. But it also generated writing serialization functions. So I can directly pass in a UTF-8 JSON writer and it would know how to write start objects, strings, properties, etc. So this is all pre-generated, compiled at compile time, no runtime code generation needed. So it's moved ahead of time. Now, why would we actually need that? So .NET 7 has actually introduced a new way of publishing applications. Have you used native AOT before? It's a cool feature. So if I actually change my program back, and would do a .NET publish, release mode for Windows, publish AOT true. What will happen is it will use a very slimmed down version of the .NET runtime, build my app, trim out everything that's not needed. So it also uses trimming, and then just put one single self-contained executable that has no jitter, no IL, just native code. And we should be able to see this. Publish, right. 1 exe, that's all you need. And I think it's just 6 megabytes. But it now throws an exception. It kind of tells me, yeah, you're missing a constructor here. And we know we have actually written a constructor, but we haven't used it in our actual code. So we also get these warnings like, this member can break functionality when AOT compiled. And it says, yeah, use a generator. So if I change that back, publish again, generating native code, and here we are. Let's try that again. And now it works, because we're running in a runtime that does not have any jitter, can't do anything at runtime. Also, it trimmed out everything that we didn't call directly, so it never saw a new call of person with that constructor being used, so it just threw it out. So you see, for some new methods of deploying, these generators are really, really useful. But that's not the only one. Let's have a look at some more. So one of them is actually on logging. These log messages, they will be like parsed. We will look for, okay, where are the tokens? Where's the replacement? How do you do that? And it's also something that can actually be pre-generated. So if I have a partial class that has some ilogger of t, I can just create partial methods, annotate it with a logger message, can pass a level, I can even set the event IDs, and it will generate some code for me. So, no, there it is. So you can see there is some struct that holds the data that I'm using. Hello. And it also emits the isEnabled flag. So if I specify log level, we should always check, hey, is this log level actually enabled before we call the actual log method? And that's generated as well. And the way to use it, we'll just call the method. There's some other useful things we can do. For example, on extensions, we can have this like log method enter. Yeah, just generate that, reuse that. It should be a bit faster and easier to use than other ways of doing it. So, actually, since I'm in a web project now, I mentioned JSON Razor earlier. So, Razor actually changed from generating the code at compile time in a separate DLL to actually compiling it inside of the compiler as a source generator, as a basically a compiler plugin. Also, if you I'm now using VS Code again, in the project file we can also tell it, yeah, if I'm actually not using Visual Studio and I don't have that inspector, please put the files on disk. So can have a look at them, can even tell it which path to write it out to. So I should see all these files under ops generated, and there's the Razor source generator. So can have a look at how does my error page actually look like. So there's a generated class, pages error, and there's some right literal. So that used to be inside of my Razor class. And that's actually what gets compiled into your application when you create an ASP.NET Core application using Razor. So, no generation at runtime. Now there's a few more that have been added. One of them is if you're using regexes a lot. For example, here I want to validate some IP addresses. Yeah, you can call new regex, pass it some string, it will try to generate a state machine, try to generate code to do like parsing and validation. You could already had the option to use these compiled regexes, but they're compiled at runtime. Now I can actually mark a partial method as generated regex, and it will generate the code for you. First thing that we notice is it actually creates a description with an explanation, which is quite useful. But we can also have a look at the implementation. So if you ever wondered how that regex parsing looks like, you can have a look at the state machine and all its go-tos, alternate branch, and so on. So couple of hundreds of lines of code just to parse an IP address. I think that's pretty interesting what this is actually doing behind the scenes. There's also probably more of a niche use case, but also when you're calling into native methods, like into DLL files, into dynamic libraries. We previously always used DLL import for that. It's like, hey, this is this DLL, I want to call a method there. And in most cases, the runtime needed to generate some stubbing code to do the actual marshalling, unmarshalling, pinning memory, and so on. With library import, this can now be also pre-generated and thus also work in AOT scenarios. So there's this function global memory status X that I want to call. Actually, let's switch that. Yeah, that should tell me how much memory I'm actually consuming. So, and what this generates is basically code that I really do not want to write myself, which is something with like pointers and marshalling. Like, yeah, I don't want to touch that. Thanks for generating that. And thanks for making it working in ahead of time scenarios. So a lot of actually everything in the .NET runtime that did this interop, so basically the native layer was now written with that generator. It also has some other options if you want to do like custom unmarshalling. So it has more extensibility options that the .NET team didn't want to backport to like DLL import, because it was very Windows specific. So, and then there's one last thing. So, I think we've heard about Maui and Blazor a lot, and we can actually use .NET just using WASM. So we can actually write a WebAssembly program that is not tied to Blazor, that just has an index.html that references the .NET runtime and my main application. That's a JavaScript file that has the boilerplate code to actually load the assembly export that it needs, call some classes, and then there's a program file that defines methods. So I can export a method to be able to call it from JavaScript. I can also mark a method, say like, hey, call this JavaScript method, or in this case property, because I need that, and please generate the code for that as well. So actually, let's build that. Or .NET Run should be enough. Perfect. Hello world. And I think we even got our hello browser output. So that's .NET running natively in WASM without any Blazor parts. And there's actually also a template called WASM console, which will build a WASM module that you can run from Node.js. So if you want to build your server-side applications using Node, but also with .NET, you can do that now. Okay. Now that was all about the generators. Let's have a quick recap with the system text JSON generator. You can also turn on and off the reflection logic. You can only generate the reflection logic. You can also only generate the data access or the optimized serialization logic. So if you want to do some custom tweaks, custom extensions, some features may not work with all the configurations. But at least the benchmark was saw a great increase in performance. And if you want to use it in your own application, so you can use it in ASP.NET Core, can register the context in the JSON options. Also, if you're using HttpClient, there's a new convenient method to directly call an HTTP API and deserialize the result. We have the Razor source generator. At least in .NET 6, it could be turned off if there were problems with it, but personally, I haven't had any problems. Works. Logging generator, regex generator, library import generator, JS import generator, and with all the generators, let's build our own. So, what do I want to do? So, there's probably hundreds of ways of implementing iNotify property changed. It's like this weird interface that we have that tells any consumer, hey, a property has changed. And since we had to do that over time, all the time, there's now hundreds of methods. I'm introducing method n+1, which is I have an interface with properties, and I have an actual view model that should have the properties of that interface generated and implement iNotify property changed. Yeah, and then there's some sample code that tries to register to the events and change some properties. And of course, that doesn't compile because the source code for the generator is basically empty. So the way we would do this is create a project. It's just a .NET Standard project. Don't forget, it has to run in Visual Studio as well, which is still a .NET Framework application, so you need to be able to run a .NET Framework. Sadly, this means no records, but still. And there's actually two different implementations of source generators. There is the iSource generator, which has been introduced in .NET 5, but now we have the iIncremental generator. So in Visual Studio 2022, we basically got a new interface. Because the old one would tell you, here's the source code, have a look at all the source code of the user, and generate your code. So you would always have to iterate through the source code, and they thought, okay, if you have more source code, it will just take a bit longer. Until they actually hit really, really large solutions, and that turned out to be, at first, a linear increase in performance, and then it exponentially grew. Because at some point, if you have hundreds of projects, or a lot of million lines of code, it would actually hit an issue with paging the parts of the memory to disk and back from disk again, so you would hit some memory perf issues. So now this incremental generator, which tries to be a bit more smarter about which parts of code have changed, what does that mean for your generator. So you basically set up like a data flow. Looks a bit like reactive extensions of what you actually want to have in the project. But let's do it step by step. So the first thing I need is I actually want to have that attribute. So I could put that in some project, have my program reference this project that contains the attribute, or I'll just generate the attribute. So what I can do on that context, register some things that are just there from the beginning. So post initialization, just add this code to the project, should be fine. That should make the target then see this attribute, and it can already use it in the IDE experience. We also have access to the compilation options, but now it's actually a bit tricky because we say compilation, there's just a provider which has this type incremental value provider that I can do a select with, which is basically a projection. So this compilation provider will send new values whenever the configuration changes. So the select is basically like a transform that we would have seen in Rx, for example. So then I want to look at the source code. And that means I need to keep track of the things that I actually want to generate. So I want to have a look at the source code and then generate, let me just close it for an overview. And that just know, okay, which implementations do I need to generate, which classes do I need to generate, what's the interfaces that I need to take care about, and what are the actual property names. And these are all I-equatable, because in order to have that pipeline be smart about which parts to run, I also need to make sure to know which things have actually changed. So if I try to use that, I have my syntax provider, which will basically give me information about all the syntax, everything that changes. So every key press might trigger some change. And there is a convenience method here for attribute with metadata name, because it turns out most of the things that people writing generators have done is just looking at the attributes. So this is actually a really, really fast method. I think it was introduced in 17.3. So it's hasn't been in there for the beginning, but it's a lot faster than trying to do it yourself in a maybe suboptimal way. So I tell it, yeah, give me everything that has this attribute. I can give it the fully qualified name. And we can also apply predicate to do some filtering before. Because I expect this to be on classes, but again, this code might not even compile correctly. Or the attribute could be there, even though it's not supposed to be there. So I make sure I only get what I expect. And then a transform. I try to get the parameters that are passed to the attributes, iterate over that, and generate the implementation to generate, which is now my data type. And I mentioned changes before, so the change tracking should work automatically if you have the right types of classes. So if you use tuples, everything should work. But you can also use a custom comparer as well. And then there are also options like combine. So I can react to changes of the source code, but from the other side, I can also react to changes from the compilation options. In this case, I'm interested if nullable reference types are turned off or on, because I might want to generate different code for that. Speaking of generating code, there's also now a method that generates the actual string. Let me quickly point out a very new cool feature in C#, raw string literals. So there's two $signs, and I have these two curly braces, so it doesn't mess up my C# that I actually wanted to write. So that helped simplify a lot of code. Yeah, and then I'm just implementing everything I need. I put the event in a new partial class. I have implement the onProperty changed method, and then for every property, I generate a backing field and a property with a getter and a setter. So now I need to actually wire this up. And I do that by registering outputs. So this is basically where in Rx it would be the subscribe method, where I actually tell, okay, that's the graph. It should be hooked up into there. So for each of these inputs, I want to call generate implementation, so it also does some projection, and calls context add source, so the source should be available. And the way to think about this is trying to visualize the graph and know that at each node, the compiler tracks what went in there, what came out, and so whenever you change something in the code, it will intelligently know, okay, you have 3 files, but you only edited 1 file, and there was only 1 class there, and then you did a predicate, you were not interested in that, and yeah, maybe nothing changed. So you really set up the data flow, and it looks a bit like Link or Rx, whichever you're more used to. So, how do I know this is working? My favorite way is using tests. So I can actually create the C# generator driver, create a compilation with some demo code, and make sure it compiles. And yeah, I implemented it differently than the last time. And that's actually a package called Verify, which does like semi-automated testing. So it's the kind of thing where I freeze some state. It's like, okay, I know that works. If I change something, it shows me what changed. So I apparently made some error. So maybe I want to take advantage of new language features here. Perfect. So, and if I say, okay, that's actually what I need, this actually puts additional files below my test class with basically what has been verified, what has been received, and it does a comparison. So the verified ones I would commit into Git, and then the generated ones, the received ones, it would check against the basically known good outcomes. So that works now. So how do I use that in my application? Because I want to get this working. And the way I can do this is use the project reference. But I don't really want just like to reference the library. I want to use the output, the DLL output, as compiler plugins. I can do that using the output item type. And then I'm not really interested in all the transient dependencies, and maybe it was also built for a different TFM that maybe, okay, net standard should be supported by .NET 7, but maybe there were some incompatibilities. It says, yeah, I'm just referencing that, I'm not using that. That's what this reference output assembly false does. So, okay, red squigglies have gone away. Let's see if that actually works. Perfect. Starting out with person, and it changed. So you can actually register to these events. So how would I debug issues in there? Well, first I could just run the tests in debug mode and set breakpoints. What I've also prepared is actually, let's reload that since I Okay. I knew something was messed up. So there it is, a copy. Now this should also be running my generator. And since Visual Studio is loading the thing, I should actually be able to just debug, attach the process, devenv, and this should be the application. So if I go into my generator and I set some breakpoints, maybe here on add source and here on return implementation to generate, and I just do this is the last name, I just do some key press, I can actually debug in here. So I've changed the interface, and if we have a look again at the actual application, okay, I can't switch back and forth. So there's two classes implementing this interface, so two classes marked as auto-generate. So 1, 2, because the interface changed for both of them. There's a few more runs for caching, and then the registering the output. Yeah, because I've done two presses. So if I change maybe only one of them, I would just get the updates that I actually need to look at. Perfect, so just one. If you're interested about the perf implications, there is a project called Generator Tracer, built by one of the people from the compiler team, that when run as administrator, can actually attach to the events that Visual Studio generates. So if I'm now, again, changing something, running things, I should see how many milliseconds which generator took to run. So that's quite helpful for debugging any perf issues you could run into with generators. So another thing we could do, so we can use source code to generate source code. We can also use other files to generate source code. So maybe I have some XML settings, XML file to settings. Maybe it's static, maybe it doesn't change that often. And I want to use that in my analyzer. First thing is I have to change the build action. Could be none, could be content, to C# analyze additional files. And then in a generator, I can use the additional text provider to look for these texts. So I'm interested in the XML settings things, and I want to generate stuff of that. So I can use sample settings, default, greeting. Okay, that doesn't work, but the file is in there. Let's check if that works. Ready. There we are. So you can have a look at the file. But maybe I want to do some more customization. So I could take this generator, ship it as a NuGet package, and then maybe the consumers would say, yeah, but I don't want to have that in the XML settings namespace. Could you use another namespace for that? And yeah, I can actually do that. I could say, okay, in your project, just set one property. Oops. Default model generation namespace, and my NuGet package will take care of that. So maybe I tell the consumer to write this in their code, and then behind the scenes, I can tell the compiler, hey, I want to see a property with that name. So if that's in the project, also pass it to the compiler. Because in MS Build, there's lots of stuff that's not relevant to the actual Roslyn compiler, things about other steps of the build, other tools. So I need to tell the logic, like which properties are relevant for the compiler. So just change it to my settings. And now it doesn't build, and now it should work again. And the way I can use this is in the analyzer config options, I have like global options. And if I use the correct name, build property dot the property name, I can actually read that value if it exists. But I can also, if you pick up there, I can also configure it on a per item level. So MS Build has these key value properties. Those are just very simple, and it has items which have more rich metadata. So in this case, I'm including XML settings item. I'm then reusing them to pass into these additional files so that the analyzer could see that. So that's something that maybe you could also ship as part of the NuGet package, some logic. But I can also set metadata in here. And again, I have to tell the compiler which metadata am I actually interested in. So on additional files, please also use this metadata. So I can actually set that on the item itself. If the item is reused somewhere else, that metadata will be passed along, and it should end up in my compiler. The only difference is I'm not using the global options. I'm telling, hey, tell me which options were configured for this additional text, which is my XML file. And then I have access to that build metadata dot additional files. That was the item type. And then that's the metadata name that we defined. So customization also per file. So that's, for example, if you have things like protobuf, maybe you want to say, hey, generate client, generate server, what do I want to do with this schema file, and that's where this comes in very useful. Okay. Yeah, I showed that. So I mentioned NuGet packages. So if you actually want to really write a generator and publish it, you really need to think about who's going to use it and in which language version. So again, they were introduced in C# 9, so any C# 9 project should be able to use it. So maybe using C# 11 features in generated code, maybe not the best idea. Also things like nullability. If I want to enable the nullable reference type feature, maybe I expect the generator to also take that into consideration. Also, if you know that the user may have messed up, tell them. It's the Analyzer API. You can also emit diagnostics, like warnings, errors. If someone's using your attributes not in the correct way, you can tell them as well. And something I always encourage doing is starting auto-generated code with this comment. Because if someone enables that feature where it's like, write everything to disk, and you have some static analysis just going over all CS files, that will show up. That's also has also been an issue with the .NET SDK when they started to auto-generate the assembly info, and it didn't have that. So that became a problem. It was quickly fixed. And again, no, users might want to set some options. And depending on which version of Visual Studio they're actually running, you might have newer APIs. So I showed you the for attributes with metadata name. Maybe that wasn't there in 17.0. Also, if you're still using Visual Studio 2019, then the incremental API isn't yet available. So one would have to implement a different package or use some magic to switch the DLL files, to use the classic source generator APIs that I think they want to mark as obsolete at some point in the future. And of course, there's a great guide on all the features you could use, the source generators cookbook. It also shows you how to publish the NuGet package. There's also a few magic lines of MS Build you need to add to that library project, but then you can publish it to NuGet, reference it in a project, and you will have the generator working for you. Some other links. The Roslyn SDK also has a few samples, especially I think for the incremental API, these ones are good. And if you just want to browse, like what are some interesting source generators to use, there are actually lists on GitHub. So, yeah, there's a lot. So maybe if you, the things that you try to do, maybe someone already did it. Yeah, I know if a property changed. There are a few implementations. So, with that, since we have 4 minutes left, are there any questions? Okay, how it works with Rider and VS Code. So VS Code just hosts Roslyn, so that also works out of the box. The only thing is you don't have that IDE thing where you can click through the dependency tree. In Rider it also works, because Rider also hosts a version of Roslyn behind the scenes. You just need to be smart about when to invalidate that code. So maybe it doesn't work for every key press, but they did a really good job of making sure that it works. So if there are no further questions, then thank you for coming, and I'll be around and available. Thanks.